Good day everyone, we're going to make a parallel circuit simulation activity based on the given values. We have here VT is equals to 30 volts, R1 is equals to 10 ohms, R2 is equals to 5 ohms, and R3 is equals to 40 ohms.
First thing you're gonna do is to put a wire, then put a voltage beside it. Since we have voltage as the first given, and just simply add some wire to connect the circuit. On the second line, we're going to put a resistor. This will be our R1. Then we're going to put current. For the information of everybody, electric current is the movement of electrons through a wire. Electric current is measured in amperes or amps and refers to the number of charges that move through the wire per second. We're gonna need to put the current in order to know the missing values, which are the I1, I2, and I3. On the third line, we're going to put another resistor. This will be our R2. And finally, we're going to put our last resistor. This will be our R3. We are already finished connecting the three resistors. What we're gonna do next is to set each resistors based on the given values. The first resistor would be 10 ohms, the second resistor would be 5 ohms, and the third resistor would be 40 ohms. After setting the value of each resistors, now we're going to proceed to the value of our voltage, which is 30 volts. In order for a current to flow, the circuit must be closed. In other words, there must be an uninterrupted path from the power source through the circuit, then back to the power source. After connecting them, the current will automatically flow. Now we have our missing values, which is the 3 amperes, 6 amperes, and 0.75 amperes. This 3 will be our I1, I2, and I3. Now we're finally done with our parallel circuit simulation. Now we're going to proceed to our problem solvings.
First is to solve the total resistance. We are going to use the third law in parallel circuit. The formula we're going to use is 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Substitute each given in order to solve for the total resistance. Substitute R1, R2, and R3 with 10 ohms, 5 ohms, and 40 ohms respectively. Next is to divide 1 over 10 ohms, which is 0.1 ohms, 1 over 5 ohms, which is 0.2 ohms, and 1 over 40 ohms, which is 0.03 ohms. Then add the 3 ohms to get 0.33 ohms. After that, cross-multiply 1 over RT with 0.33 ohms over 1, which will have 0.33 ohms times RT is equal to 1. Afterwards, divide 0.33 ohms to 0.33 ohms RT and 1. The total resistance of the parallel circuit is 3.03 ohms. Second is to solve for the intensity 1, intensity 2, and intensity 3. The formula we will be using in the intensity 1 is equal to voltage 1 over resistance 1. Substitute the given, the voltage 1 and the resistant 1 with 30 volts and 10 ohms. Divide 30 volts with 10 ohms, the intensity 1 is 3 amperes. For the intensity 2, the formula we will be using in the intensity 2 is equal to voltage 2 over resistance 2. Substitute the given, the voltage 2 and the resistance 2 with 30 volts and 5 ohms. Divide 30 volts with 5 ohms, the intensity 2 is 6 amperes. Lastly, for the intensity 3, the formula we will be using in the intensity 3 is equal to voltage 3 over resistance 3. Substitute the given, the voltage 3 and the resistance 3 with 30 volts and 40 ohms. Divide 30 volts with 40 ohms, the intensity 3 is 0.75 amperes.